Good morning. Good morning. Today, what I'm going to show you is how to basically run our Ed puzzle. So this is, again, Mrs. Sullivan. I am watching, or not watching, I am recording right now. I'm going to actually go ahead and start recording our notes for today. So our notes are on lesson 1.1 in our textbook. And so remember that as I am doing the recording, as you're sitting there watching, you should have paper and pencil out and you should be doing the examples with me. I would highly recommend titling your notes. Lesson 1.1, we are going to be solving simple equations today. All right, solving simple equations. This lesson is going to take me probably 10 minutes to get through, if even that. But this is our first practice one. So we're watching it in class together, I'm assuming. And you are observing how Edpuzzle works. So lesson 1.1, solving simple equations. Okay, when we start off with saying things like solve and equations, these are math words. And a lot of times we use math words and we don't necessarily know exactly the precise definition of it. So let's start off with just defining the word equation. Okay, an equation, a couple things. First of all, it must have an equal sign. In order to use the word equation, I have to see an equal sign somewhere in that math sentence. Equations also have a combination of variables. Sometimes there's only one variable, sometimes there's more than one. So we'll put the S in parentheses because it's an optional, either one variable or multiple variables. Combination of variables and numbers and operations. The operations in math, these are the things like adding, subtracting, multiplying, dividing. This is what tells me what to do in the problem. What is kind of the action or the verb, I guess. Now, when we talk then about solving, I was just teaching this and re-emphasizing this to my upperclassmen because we say the word solve all the time in math. Like, what am I doing in this problem? I'm solving it. But see, maybe not really. What does it actually mean to solve an equation? Well, the answer, anytime I see the word solve in the directions, I'm looking for something that says x equals and then a number. It can be a decimal, it can be 0, it can be positive and negative, it can be more than one sometimes. But anytime I see the word solve, I'm looking for an x equals answer. Another thing is that when I'm talking about my answer to a solved problem, the number is called a solution. And anytime we have a solution, it too has a definition. Basically, a solution is some number that when I plug it into the original equation, I get a true statement. That's kind of a long definition. What I mean by a true statement is something where I get like 3 equals 3, or 0 equals 0, or -10 equals -10. I get some number equaling itself. That is a true statement. I'm going to use that phrase a lot this year. True statement. Now, I'm recording this video and I'm kind of sleepy, and so I'm yawning a lot, and I'm really sorry. I hope that that doesn't come through in a funny way over the video. So we'll see how it goes. All right. Maybe someone can keep a tally of how many times I yawn during the video. That'll be funny. Okay, let's get into some actual action steps. How do I go about solving an equation? To solve an equation. Now, when we are solving, one thing that's helpful for some people to think about is that, remember order of operations? Remember PEMDAS? Has anybody seen that before? Okay, this is how, if I am evaluating an expression, this is used to evaluate. So if I had something like 3 plus 2 times 7 minus 1 divided by 3. I have no idea what that is. I was just pulling numbers out. But if I want to figure out what is this, if I'm going to evaluate it, then I'm going to get a number answer. So I'm going to do my parentheses, then my exponents, then my multiply or divide from left to right, and my add or subtract from left to right. Oh, someone mark a tally. There's a yawn. Okay. When we are solving an equation, we actually do order of operations backwards. So what I mean by that is if I see an equation that says x minus 3 equals 10, the first thing that I'm going to do in order to get x by itself, I say that up there. If I'm solving, I want an x equals, so that might be something helpful. Get x by itself. If I'm going to get x by itself, I'm going to say, okay, what's happening to my x? I'm taking x minus 3. This subtract here is where I'm going to undo first. So we have these things called inverse operations. And these are operations that undo each other. Okay, you already know what they are. So when I say, well, what is the opposite of add? You would tell me subtract. And if I said, what's the opposite of multiply? You would tell me divide. But they actually work in partners, because if I said, what's the opposite of divide? You would tell me multiply. And what's the opposite of subtract? Add. And so we undo by using the inverse operations. So inverse operations undo. And I love this word. I use this word undo all the time. So usually when I'm walking students through a problem, the first thing I'll say is, what do you see? Or what operation do you see? Or another way I might say this is, what's happening to the x? So when I look at this, I say, oh, well, I'm taking x minus 3. That's what's happening to the x, the minus 3 part of it. And so then I would say, okay, well, how do I undo minus 3? Well, what's the opposite of minus, or what's the opposite of subtract? Add. So I'm going to undo this minus 3 by adding 3, and I have to do it to both sides. Have to. Because what ends up happening is that this negative 3 or this minus 3 and this plus 3, they cancel, which means they give me 0. And so they're gone. They go away. And so on the left side of the equation, all I'm left with is the x. The equal sign comes next, so it's going to come straight down. And then I'm going to do 10 plus 3 is 13. This is my answer. It is my solution. It is an x equals a number answer. And not only that, if I were to take 13 and plug it back in for the x in my original equation, so let's say 13 minus 3 equals 10. Is that true? Well, what is 13 minus 3? 10. So 10 equals 10 is a true statement. This is the proof that shows that x equals 13 is, in fact, a solution. Okay. Hopefully, we have these questions written down because this, again, is how I talk you through problems. Let's get another one. They're going to say just as basic as that, though. Let's say this one. If I had x divided by negative 2 equals 7. The first question I'm going to ask you is coming back up here. Again, these two can be the same. What's happening to the x? Or what operation do you see? Now, I make you start there. Please don't tell me multiply right now, okay? I want you to tell me over here, here's my x. What operation do you see? Well, I see this bar here, which tells me that I'm dividing. So I see divide. We always start with our observations. And then from that observation, then we can figure out what to do next. So what do I do? Or how do I get rid of a divide by negative 2? How do I undo a divide by negative 2? Well, what's the opposite of divide? And you're going to tell me multiply. So we're going to multiply by whatever number we're dividing by. So I'm dividing by negative 2. So we multiply by negative 2. And we do it on both sides. And that's because our times by 2 and our divide by 2 cancel each other out. And that means that I get x is by itself on the left-hand side. And then 7 times negative 2 is negative 14. So this is my answer. It is my solution. Now, a lot of times with some of these more basic problems, you can figure it out. You can probably look at the equation and figure out what the answer is without me having to walk through the steps like we do. If I look at this, I can look at this equation here and say, what number x, okay, anytime I see a variable, I can read that what number. So I'm going to say what number, when I multiply it by 2, is going to give me 40. You can figure that out on your own without following my steps, but I want you to follow the steps, please. And so I want you to think, okay, what operation do I see? I see multiply. So how do I undo multiply? divide. And I'm going to divide by whatever number I see. Divide by 2. They cancel because they undo each other. And so x equals, what's 40 divided by 2? 20. That is my answer.